The core daily activity of a software engineer is undergoing an immediate structural change. The actual typing of code is being abstracted away. Historically, software engineering has always been a race to escape manual translation. We build abstraction layers so we can focus on logic rather than the mechanics of execution. Look at this diagram of the foundational computing stack. At the very bottom, we have the raw hardware layer, the physical processors and memory. To avoid writing instructions for specific processors, engineers built the operating system layer to manage hardware resources automatically. On top of that, we placed the compiler layer, which translates human-readable logic into executable machine code so we don't have to write in binary. For decades, we've lived in the high-level language layer. This is where engineers spend hours writing and memorizing line-by-line syntax in languages like Python or C++. But today, a new layer is locking into place: natural language orchestration. Here, AI agents handle the syntax generation based on plain English directives. The primary value of an engineer is shifting from the ability to type syntax to the ability to direct automated systems. This change resets the baseline expectations for the entire industry. Among early career developers, there is an assumption that delegating syntax to a large language model means you can bypass deep computer science theory. This assumption is backward. We are entering the proficiency paradox. As code generation accelerates, the damage caused by poor architecture becomes harder to contain. When an AI generates hundreds of lines of code in seconds, domains like system design, algorithm efficiency, and API logic become your only safeguards against structural failure. If you attempt to use natural language orchestration without these foundational concepts, you will generate massive amounts of unoptimized, vulnerable code without even realizing it. Tech companies are already adapting. They are actively rejecting developers who rely solely on prompting because those developers silently introduce technical debt that scales alongside the AI's output. Let's look at a standard engineering task to see exactly how this process breaks down: building a secure user authentication flow. This failure tree model shows how the process breaks down. A developer using the blind prompt approach simply asks the AI to build the feature, which branches downward into a massive, unconstrained web of generated code. Generative AI operates probabilistically. It predicts the most likely sequence of tokens to satisfy the prompt. It does not independently engineer a secure solution tailored to a specific system configuration. Because the constraints were vague, the output contains hidden flaws. The AI might provide a standard login function, but miss edge cases involving concurrent user sessions. Furthermore, the default query routing it generates is often unoptimized, creating severe performance bottlenecks the moment traffic scales up. The real danger lies with the engineer. Because they did not actively design the system's logic, they lack the specific mental model required to spot these subtle vulnerabilities in the output. Pushing this blind logic into a production environment creates a high risk of cascading failure under load. AI models are efficient at outputting syntax. They are incapable of independently assuming the liability for secure system architecture. To safely utilize natural language orchestration, you have to constrain the AI's probabilistic output with explicit engineering rigor. As the right side of the model shows, this introduces a mandatory pre-coding step. Before generating any syntax, the engineer must define explicit architectural constraints in plain text. This means mapping out the exact data schemas the application will use and establishing strict flow boundaries within the prompt itself. You must also pre-calculate the specific edge cases, like those concurrent login conflicts, and list exactly how the AI should handle them. Finally, you detail the exact sequence of API interactions and the required security protocols, using precise English to lock in the logic. When you execute a constrained prompt, the AI is no longer guessing. It is forced to generate syntax exclusively within your predefined logic parameters. Compare this output to the blind prompt. The resulting code is heavily structured, optimized for your specific database, and free of architectural warnings. This methodology ensures that even though you didn't type the semicolons, you maintain total intellectual ownership over the system's behavior. Translating deep theoretical computer science into precise English constraints is now the definitive skill of the modern software engineer. This methodology reconfigures the daily software development lifecycle. This bar graph shows the legacy time allocation model for a software engineer. Historically, a developer spent about 80% of their day writing boilerplate syntax and 20% reviewing code. Spending the vast majority of your working hours acting as a manual translator for a compiler is no longer a competitive use of engineering resources. AI-assisted development demands an inverted workflow. You now spend 20% of your time drafting plain text architecture and 80% on critique and security review. That large block of time is dedicated entirely to rigorous reading, debugging, and stress testing the syntax the AI produced. The smaller block is reserved for purely strategic architectural planning before the AI is even engaged. You have to treat AI-generated code with the exact same intense skepticism as a pull request from an untrusted third party. It is the only way to prevent rapid system degradation. Looking at the macro perspective of the tech industry, the computing stack has definitively added its newest layer. At this natural language abstraction layer, development is a continuous loop. The human provides strict constraints, the AI generates the syntax, and the human verifies the logic. Memorizing language-specific loops or obscure boilerplate syntax offers zero market value moving forward. The machine already knows it. Your professional action plan requires 2 steps. First, abandon pure syntax memorization drills. Reallocate that study time to mastering core system design principles. Second, build projects strictly using the inverted workflow. Write out your logic, prompt the AI, and spend the majority of your time practicing high-level code critique. The industry compensates engineers for engineering scalable, secure solutions. It does not pay for typing speed. The paradox of generative AI in software engineering is that making code easier to write makes bad code incredibly easy to deploy. The AI is merely an execution tool. It is a highly efficient hammer, but it still requires a skilled carpenter to direct its force. Early career developers now face a binary outcome. Those who master system architecture and constraint mapping will manage complex systems at a scale that manual development cannot reach. Those who rely on blind prompting to do their thinking for them will quickly become obsolete. Human oversight remains the final layer of control, ensuring that automated execution aligns with the intended architectural outcome. To survive this era of software engineering, you must permanently stop acting as a human compiler and step fully into the role of the system architect.